So we're back. Comp Dev blog, planar projection. So in the last video, we went over the geometry setup. So this goes out to projection. So now let's jump into the Copernicus setup, and we'll walk through that. So let's see. All right. So here in Copernicus, got my cheeky egg coming in. So that's my in texture. So that's what I want to project onto. And on my sum import, I'm have it look at the out projection node. Now, to make sure this is working and that I can put the same data back onto the geometry, over in my shader here, I'm actually grabbing the out geom. So before I do all this wacky stuff to it, I want to make sure that it'll still look good on the original geometry coming in. So that's why I did that, just as a failsafe. Okay, first part is how in the world, how do I get the UV information, so my UV project information, how do I morph that into my UV information? That was like the hardest part. Like I couldn't figure it out. So, and I didn't figure it out on my own. I'll link the tutorial that I found, and it's kind of buried within the rest of the information, but it did have one part that really worked out for me really well. So I have this op import. I'm looking at my projections. Down here is what I'm doing, how I'm doing the UV translation. And it's literally one line of code. It's this Wrangel and it's this line of code. So I'm saying I made a UV output and I called that UV project. So I'm saying at UV project equals, and it's this UV sample node. So my UV sample node says take my first input, which is this guy here, that's my projected pig. So take that first input and then take my UV project information and push it onto, or make it based off of my UV projection at each point in space. What? Okay. So I'll say that again, like, cause I had this, like right now, everybody's pressing the stop button, but just hang with me. Just hang with me. Just trust me. It'll work out. It'll be okay. So first, context, right? We've done that before. That's easy. What geometry am I operating on? I'm operating on this geometry. This geometry has two sets of information. It has a UV coordinates and project UV coordinates. So basically, what this is saying is, it says wherever this is in this space, find this information and write it out. It's very confusing. If you do nothing else than just screen grab this and copy it and use it over and over again until you understand it, that's a win. Okay, so basically now I have this information. So just like we were doing last time with the warp projection, this is the human brain is not meant to understand what this is, right? This is raw information encoded into color. But one thing I do know is that we have to change our space, right? Because this is in UV space. All of this stuff is happening in UV space, right? So remember, our UVs generally go from 0 to 1 this way and 0 to 1 this way. And you can kind of see this. You can kind of see a faint outline of the pig head, like right here, and then it just stretches out. Now, the UV space in Copernicus goes from -1 to 1. So I need to stretch this out. So I basically need to move it down here. So that means I need to transform that. So I'm going to do a transform 2D over here. So let's clear this out. So on my transform 2D, right, I'm moving it -1. So I'm moving it 1 over and 1 down. So basically this corner comes down to here, and then I'm scaling it up by 2. So I'm just basically renormalizing this to -1 and 1. So if I do this transform, then that's starting to look like our pig head again. And then this clamp, what it does is it keeps values from going outside of this space. You can turn that off and you'll just get repeating textures. So I might put that as a user input, but that's what the clamp is doing there. Okay? So no change. Now, how do we test this? So we just test it with, a UV project, just like we did before. So I have my egg coming in here, and then, so I'm taking not UV project, UV sample. So I'm gonna set this to texture. So my UVs are gonna be these newly configurated transmorphic eyes, or whatever you want to call it, these new UVs that we've pushed our projection UVs into our texture UV space, and then I'm taking a texture here. It's like, okay, well, that looks kind of promising, but it's still really hard to see until you put it on a on a piece of geometry. So I'll just kind of circumvent all the stuff that I have going on here, and let's plug that into our texture here. Oh, I need to convert this. I get RGB. Let's slide this down into here, and this down in here. So yeah, that's working. That's totally working, right? Now, these are the things that I was talking about before. So my projection is over here. There's nothing that says that don't, in the situation that we have right now, or the setup we have right now, there's nothing that says don't go over to the go over to the other side, right? So that's what masking is going to be for, and that's what we're going to use all that information that we pulled from the projection parameters down into our vector geometry, which we will then rasterize, and that's what that whole top line is doing to make these masks so that it doesn't project on the other side, or we can fade the projection away from a point and do all that stuff. You know, I think this is a good spot. This is a good spot to stop. This is a good spot to stop. So we went. So this is huge. This is huge. The implications of being able to push one set of UV data into another set of UV data is mind blowing. Like I've literally never been able to do this in a software package before. I mean, like I'm sure there are software packages that can do it, or they're doing it under the hood, but to have it exposed like this is just. Yeah, it's amazing. So, yeah, so hopefully you're still with me. Hopefully you got something out of it. And yeah, I'll see you in the next one.